Okay, so we're going to have a look at another question, again from the HSC 2020 Standard 2 Maths paper. This is question 18. So this is a networks question. So we're told the diagram represents a network with weighted edges. Draw a minimum spanning tree for this network in the space below and determine the length. Okay, so we need to reproduce this diagram. So we have this length is 2, this length is 3, this length is 5, this length is 3, this length is 2, this is 3, this is 4, this is 1, and then we have a whole bunch of nodes all connecting in the middle here, all with length 2. 2, 2, 2, 2. This is A, B, C, D, E, F, G, and H. So we'll use one of our algorithms to do this. The shortest path, the minimum spanning tree algorithm that we can use is start at a particular node, only ever move on the shortest path away from that node available. So we're going to start at A. We can only go to B, so we have to do this. Now we can go down to E or up to C. They're both 3, so it doesn't matter which way we go. We'll go down to E. Now we can either go up here to C, 3, or up here to D, 2. 2 is less, so we'll go up here to D. Now we have lots of different paths. We can go from B to C, which is 3. We can go from D to C, which is 3. D to F, which is 2. Or D to H, which is 4. Of those 4 possible paths, D to F is the shortest, so we'll take that. Essentially, the gimmick of finding the spanning tree is you start at a node, only ever follow the shortest path possible from all the nodes you've reached. You keep doing that and you'll get a minimum spanning tree. So now we can go this way to C, we can go this way to C, we can go this way to H, or we can go to H this way, to G this way, or to C this way. We're going to pick one of these 3 because they're all of length 2. So we'll go up to G this way. Now, of all of the paths we can choose, the shortest has to be from G down to H. And now we just need to pick one more path. The shortest one to get to C is this one. So this is a min span tree. So this is a minimum spanning tree in this case. Now we've also been asked to find the length. Well, the length is just the sum of the weighted edges. So 2 plus 3 plus 2 plus 2 plus 2 plus 2 plus 1. 2 plus 3 is 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the length of our minimum spanning tree in this case should be 14. Now in terms of the marking, you get 1 mark. So this is part A of this question. In terms of the marking for part A, you get 1 mark for a minimum. You get 1 mark for correctly identifying lengths based on the diagram. So essentially, if you do anything involving spanning trees, drawing some kind of tree, trying to find values of lengths or something like that, you'll get 1 mark. The second mark, you'll need to have a spanning tree. Doesn't necessarily need to be a minimum, and you'll need to calculate its length. So if you have a tree, but it's not a minimum, and you've calculated the length, that'll get you 2 marks. And then the third mark, you'll need to have a correct minimum spanning tree and the length. Now this question does have a second part. This question has a part B. We're told the network is revised by adding another vertex k. Edges AK and CK have weights of 12 and 10 respectively as shown. What is the length of the minimum spanning tree for this revised network? Okay, so if we look at the spanning tree we had for our last network, the only thing that's changed is a new point K has been added. So a point up here, K has been added. This is 12, this is 10. If we were continuing on our spanning tree, we would travel from C to K, an extra 10. This is now the new minimum spanning tree. This is a revised minimum spanning tree. the length of the revised minimum spanning tree is the length of the old spanning tree plus 10, which is the shorter weighted edge distance to get to k. This is 24, and so this means that the length of the new minimum spanning tree, or the length of the minimum spanning tree for the revised network, is 24. And in order to get this mark, this is just worth 1 mark, this part, you need to get 24. So pretty much if you've got the first part, you can get this part. If you haven't got the first part correct, it's pretty much impossible to get this mark. So this is how question 18 works.